Hey everyone, this is a quick video on how to make a ISA backplane. This is going to be first of a series of videos I'm going to produce on how to make your own 8088 IBM PC compatible computer. The ISA backplane is just a PCB with slots that allows you to plug in ISA expansion cards. Each card offers the ability add additional functionality to your computer. Cards are available to provide video functionality as well as input-output, serial, floppy, IDE capabilities. This ISA backplane has post-code functionality as well as a circuit to implement the power and reset buttons prototyping area. It has a serial header as well as LED indicator lights for the various bus voltages. This board also offers a negative 5 volt voltage regulator. Many ATX power supplies do not offer negative 5 volts, which is commonly used for many retro sound cards. The board also has a standard ATX power connector, which allows you to use modern power supplies. To make it easier for you guys to follow along, I've put a link in the description of where you can get these components. We're going to need some basic tools to put this together, which is basically a soldering iron, some flux, and rosin core solder. We're also going to need a multimeter to perform some tests before we power up the board. That's basically it. There's not much involved here as far as tools are concerned. We start with the shorter components, which are the resistors and sockets. They go in first, and then the capacitors, the ISA slots, the LED lights, and finally the ATX power connector. Resistors limit the flow of current. They are commonly used in circuits to limit current to LEDs and to pull up or down the voltage for logic circuits. The first and second resistor R1 and R2 are 10K, and they are used to pull up the resistors for the power supply control circuit. This circuit drives a flip-flop which sends the PS on signal to the power supply when triggered by pressing the power button. The flip-flop triggers on the positive edge, flipping the output on pin 9 on each button press. Next is the R5 and R6, which is used in the postcode display circuit. Next few are current limiting resistors for the voltage rail indicator LEDs. Second to the last one is for the external power LED. The last one is part of the voltage divider circuit for the power supply control circuit. Next, we flip the board over and solder the components in. Next, we cut the leads. In this part, we're going to install the sockets. Some sockets might have bent leads due to shipping. In that case, just straighten them up. They're pretty thin. You can straighten them up. Next, we solder the sockets in on the other side. We proceed on to installing the bypass capacitors. There are quite a few of them. Each slot gets its own set. We proceed on to installing the bypass capacitors for the chips that control the post codes. Now, depending on the version of the kit, you might have gotten resistors to place over here, or sockets. So, in this particular case, I'm going to be using sockets. But if your kit has included resistors, if you have resistors in your kit, then you would place the resistors across these two pads over here. Next, we install the ATX power connector. Take note of the orientation of the connector. You'll see that the power tab, for the connector is towards the left. Just orient that accordingly on the PC board. The original version 1.1 of the board had the ATX power connector holes spaced a little too far apart. In my redesign, I actually modified them to be a little closer. Next, we work on installing the LEDs into the board. These LEDs indicate the power rails, and take note of the orientation. The shorter lead is the negative. Next, we put in the negative 5 volt power regulator. Next, we put on the diode. Again, the diode is polarity sensitive, so the black band should be oriented appropriately based on the printing on the board. Next, we install the header pins. Next, we install the LED display and the 9-pin serial port. Next, we install the power switch and the reset switch. Please take note of the orientation. They should just snap right in. Flip the board over and solder the components in. Now we install the IC chips into the sockets. You will notice that the leads for the chips are a little wide. Just use the table to bend them just slightly so they fit into the socket. Also, the orientation for the chips are important. So on the chips you'll see either indentation or some type of indicator. Just match that up to the orientation that you see printed on the board. Now it's time to install the ISA slots. The ISA slots you can install on an as-needed basis. It's a lot of soldering and it can get a bit boring, so you know, exercise that option. Once at least one ISA slot has been soldered in, you can hook it up to the power supply and power it up. Make sure your workspace is clean of any metallic items to prevent any shorts from happening. You will see the status LED light up as soon as you plug it in and turn on the power supply. Next, we install the jumpers onto the board. Visit my website for documentation on which jumpers need to be placed in what position. Once the jumpers are in and you can plug it into your power supply and turn it on, we will be checking the voltage on each of the ISA slot pins. So I've included a pinout diagram of the ISA slot. So use your voltmeter to verify each pin. This concludes the assembly of this board. I will be posting another video describing the assembly of the XI88 processor board, so stay tuned for that. If this video was helpful, hit that like button and subscribe to my channel so you don't miss out on future videos.